All right, what's good? Welcome to the cool room, the nerd room, the record lair here at Goatsbeard Homestead. My name is Andre, also known as Dr. Andre Sirois. On February 18th, 2025, I gave a very stimulating lecture at the Eugene Science Center for the Lane County Beekeepers Association, the first of our four-part series for beginning beekeepers called Bee Biology, Know Your Livestock. And you can see the footage right here, and guess what happened is I didn't turn on my microphone. It was a great talk, great studio audience, everybody was feeling good, and so unfortunately I didn't turn on my mic and all we had was radio static. So I'm gonna get that out of here and I am going to deliver the same talk because that information on the basics of bee biology is just fundamental knowledge for beginning, intermediate, and lifelong beekeepers. We always gotta know about the basics of our livestock, and that's what we will talk about today. So I'm so happy you're here. Shout outs to all the people who came out to that meeting and asked good questions or asked questions that I didn't understand. All that, appreciate that. So, and thanks for tuning in, and make sure to subscribe to the Lane County Beekeepers Association YouTube channel and our Instagram. All right. So a couple things here, and I just want to point this out from the beginning. We live in America, and well, I presume you do, and honeybees are non-native here, meaning they're not native pollinators. We have many different types of pollinators here in the United States, but honeybees, when any honeybees are here, the honeybees you have, they are non-native, meaning they did not originate in the United States. We are talking about the European honeybee, right? Apis mellifera, which is Latin, which, guess what? You will never ever say that except for when you give a talk to a beekeeping association, or if you're a Romance language scholar or a lawyer, hey, I'm gonna go just check on my Apis mellifera hives right now, or man, I love honey from those Apis mellifera. You'll never use it, but it's important to know from a biological perspective, because there's so many different types of honeybees. But the honeybees that we have in the United States here are European. They originate from Europe and from Africa. So, but they are not native. That's important to know. Now, one thing to also understand too is that honeybees are bred for certain characteristics, whether it's they produce a lot of honey, they're not very defensive, they don't sting a lot, aren't very super protective, they're a little more docile, or they maybe overwinter better in colder climates, or are resistant to certain pests, etc. These, they're bred for certain characteristics, right? And that's very important. And the main thing is that, essentially when you have a hive, you are making more bees. Bees are reproducing inside of your hive. The colony is reproducing, right? And you have that happening on your property. With that in mind, good people, you are a farmer. Now listen, maybe you did not want to be a farmer. I certainly did not want to be a farmer, right? But you are farming, you are reproducing, you are producing a harvestable, product in the honey, in the wax, in the propolis, etc. Okay, and this is really important, accepting and understanding that bees are livestock. They are like cattle or goats or chickens, right? And those types of animals we typically think as livestock, and we treat them like that. Respect, and we're accountable for our actions, and we're really, we notice what happens, or we should be noticing, what they're foraging and their health, etc. And what happens a lot of times, with people that get bees is they're insects, they're bugs, and we don't think of them as cows, right, or something like that. And so kind of adopting that mindset is really, really helpful, because that's really what happens. And I get it. You got bees to pollinate your strawberries. You got bees because you like honey. You got bees because you like bees. It doesn't matter. You're farming, This is agricultural activity and you're engaged in it. So it's important to know. I have a picture here of my beautiful son, 7 years old, holding a partially drawn frame of honeycomb. And I just like to show this, because for a lot of beginning beekeepers, there's a lot to know, right? And there's going to be a lot in this talk today, this discussion or presentation that I'm giving to y'all. But my son can do it. I can do it. Like if we can do it, you can do it, and, by making yourself knowledgeable about your livestock and various things about them, you'll get confident, and I'll talk about that in a second. So my approach to bees is really grounded in livestock. I really adhere to that and respect them in that sense, okay? And I'm accountable for what happens to them, and I do my best, to keep them healthy, and it always doesn't work, and it's not my fault, in so many ways, but it can be if you're not attuned to them as livestock. That's really important. But my approach to beekeeping is not, frolicking around the bee yard half naked or, whatever. I do that with, a veil on at least. But, I'm not saving the bees and all that stuff. I'm approaching it as a very practical livestock perspective. But you see this picture of me here rocking in the bee yard, flexing the bee guns, which for y'all, once you start handling 60, 70 pound, 50 pound boxes of bees all the time, you're going to get etched out. So, cancel your gym membership now. It's time to get strong. So just, a little bit, which sort of grounds my perspective in this. And I like to show this is like, I come from a long tradition of farming, and that has in various ways, come back around after a long time of, not being in tune with that and not wanting that at all, has grounded me. So, here's a cool picture of my family homestead in northern Maine in the 1890s, which then eventually grew to this awesome commercial potato farming operation that we had. And then you can see this beautiful photo of my Nana and all of her brothers and sisters outside the sugar shack where they would refine maple syrup up in Canada. And then of course here's the OG, inspiration for me in the bee yard is my great Uncle Ron. Here he is in 1981 holding a deep frame of honeybees, and I, always would see him in the yard when we go up there and visit them. Never went in there, but that kind of sparked my at least initial interest in it. Don't go in the yard, you'll get stung. Didn't want that. Wish I did, and wish old Uncle Ron is around now to talk to him about how he kept bees. But all that kind of grounded me. But if you see this picture of me right here pouring a package of bees into a box, I was literally crapping my pants at this moment. And the reason why is this. This is about 4 years ago, spring 2021. I'd had a hive on my property for a year that I never touched. I would just drink whiskey and watch them fly in and out. And I knew I was getting a package in April, and I had all winter to prepare, to read, to watch videos, to engage in Lane County Beekeepers Association club meetings, which I did absolutely none of. I was 0% prepared at all for this. And some of y'all may be there as well, and we're trying to get y'all over that hump here. But I remember this moment where I'm dumping the bees in, and my mentor Patrick's Waters, and my mentor Patrick Waters was there, and I'm dumping these bees in, and I got stung on my hand. And at that moment I'm like, have I ever been stung by a honeybee? And the reality was I don't think I had been. And my arm swelled up so crazy and burned like hot fire. And I was like, oh shit, I don't think I'm gonna be able to do this. You know what I mean? And here we are years later, a lot more confident, feel a lot better. Been stung a bajillion times and love it. It makes my hands feel good once that swelling goes down. But at that moment I was so unprepared, and I just really learned through doing, which is probably not the way we would recommend, but study up, learn about your animals. So when we're approaching bees as livestock or any livestock, right, I suggest there's sort of a Venn diagram here. The first thing in what we're going to talk about today, which is biology, is you got to know about your livestock, how they function, their social order, what they eat, what they do, how they procreate. And there's a lot of things you'll learn there that maybe you had no clue about. Like when I first got chickens, right, I had no idea, first of all, that they don't lay eggs forever, that there's a finite amount of eggs in a hen, just like there are in people. The other thing I didn't know is that the eggs come out of the same hole that all that chicken shit comes out of. Good thing to know. I never knew goats had 4 stomachs, all this stuff, so learning about your livestock really is super duper important, about the biology of them. And that's what we're covering today. In our second series, we'll be talking about infrastructure, protecting the livestock, protecting ourselves, but really infrastructure is so important in understanding that, which Storm and Norman Jarvis, president of the club, will be talking about in our next installation of Beginning Beekeepers by LCBA. After that, you need to know, what is their nature? What's their natural inclination? And you need to know how to work within that and around that. And for bees, their sole drive, everything we talk about today is really predicated on the sole drive of reproduction, basically reproducing their genes, getting their genes out there as much as possible. So reproducing the colony, and they do this by casting off swarms, and which Ham will talk about in our third installation. And then lastly, you need to know how to manage and care for your livestock. You need to know how to help them. You need to understand what's going well with them, what's going wrong with them, and address it and be able to sort of, negotiate and try to answer questions that you may have. And so Fanta will be talking about that in our fourth installment of Beginning Beekeepers. So, tune in for all 4 of them in our meetings and here on our YouTube channel. And what happens in sort of the center here of the Venn diagram is, hey, you're going to have a lot of questions. Beekeeping is not that easy. Throw some chickens in a field, they eat bugs and grass, keep them protected. It's fairly easy. Throw some goats in a field, it's fairly easy. The science of it isn't as complicated. I know lots of great livestock farmers who cannot overwinter and keep bees to save their lives. So they can do everything else, just the bees are the hardest. And that's not to deter you, that's actually to excite you. There is never a boring moment, but you're always going to have questions, and you always should have questions. Even when you're a master beekeeper, and you're always going to maybe not know something. And that's really important, but it's important to always keep asking questions. And at the beginning, you are going to have bajillions of questions. But as time goes on, you start to have answers for those questions. And maybe those answers to those questions turn out right. And sometimes they don't. And then you ask more questions. It's very important, but you're supposed to, get a little confidence. And that's a big part of bee farming and beekeeping, is to, build confidence around that. But never get too smug, you know what I mean? If you are a real know-it-all, or someone who thinks they're never wrong, you will develop humility by farming bees. Let me tell you that. They keep you very, very humble. But there's always new stuff to learn. There's always, something going on inside of a hive. So it's always really, really interesting. I'm someone who gets bored of things quite fast, and that's why I love bee farming, is that there's always some level of investigation going on. So those are the 4 building blocks to a successfully keeping livestock, and we're going to go through those things in our discussions at club and here on our YouTube channel. So let's just talk about this. You probably, if you've never kept bees before or had bees, you've probably seen bees, honeybees. You may even think they're yellow jackets, or yellow jackets are honeybees. The thing is that when you see a bee out probably foraging, drinking out of a flower, you have to understand that is just a bee. That is an organism. And that bee is not self-sufficient, meaning that bee relies on her superorganism, right, which is the colony, right, that she exists in. And the colony is all of the other bees, and they all have their very specific roles and do very specific things in this massive, amazing, super efficient, highly functioning, highly rational superorganism, right? So the individual bee is beautiful, but she's really nothing without all of her sisters, her mother, and some of her stupid brothers, the drones. Don't hate. All right. The important thing, the distinction to make is that this superorganism lives in a hive. And a hive is simply this, it's a cavity. In nature, where honeybees would typically exist, right? A hive would be typically a dead tree, right? So a hollowed out tree is where they would prefer to live, 7 to 10 feet off the ground to keep them away from predators, etc. But for us, they live in boxes. And why bees are livestock, really, right, is that they live in boxes that are close to the ground for the convenience of the bee farmer, for the beekeeper. That's not necessarily where they want to be, but the box that we put them in emulates the tree as best as possible. That's what's supposed to emulate. But it could be anything, a water main, like a black storage tub or storage tub that you have out behind your house, your attic, your storage shed, etc. They just want a cavity that they can fulfill. But this colony is super, super duper amazing. And the superorganism is the colony itself. The colony lives and exists inside of the hive. Now, as I said, they are very efficient, super structured, and opportunistic, meaning they are going to, forage as close to their hive as possible, as close to where they live as possible. And that could be the hive next door that's weak, where they take everything from them, or it could be the candy factory down the road from you that's discarding all this sugary mess that they're turning into honey, and so etc. But very efficient, highly rational, what the modern multinational corporation would love to be like. But the thing is within the hive, within the colony that exists in the hive, is that there is no CEO, there's no CFO, there's no majority shareholders, right? Every single bee is invested, and they all profit equally off of the success of and the health of the colony. And that's very important. It's a very democratic space inside of there. Okay, where no one is more important than someone else, necessarily, which we'll talk about today. All right, so some basic bee anatomy. Know about your bee. Well, clearly, one thing a bee has is a head. They also have a thorax, and understanding what their thoraxes look like is very important. So for female worker bees, they'll be a little bit fuzzy. For the queen bee, you'll see it's a very shiny thorax, and that's important. The hairs are, part of the pollination process, and the queen bee doesn't pollinate, so she's not very hairy. Another important part of the bee to understand and to be able to distinguish is their abdomen. And you'll see that, workers, drones, and the queen bee have very different sized abdomens. The thing that we probably most associate with bees are their stingers. Now, we all know about this. The stinger is probably the most, thing that we're afraid of. But only worker bees have them that we have to really fear, although the queen bee does too. Drone bees do not, boy bees do not, and I'll talk about that. The stinger also has a muscle sac, so when they sting you, it's a barbed stinger. It gets into your skin, and if you don't scrape it out, the muscle sac will, pump the venom continually into you. So the other thing you'll notice on the leg of worker bees is what's called a pollen basket, and this is where they store pollen when they're foraging pollen that they bring back, and we'll see videos and images of that later in this presentation. Okay, a few other things. Obviously, they have eyes, and I'll discuss that in a second, and their antennas. And the antennas are like their main sensory part of the bees. It's how they, you know, taste and test, you know, how sweet the nectar is for a flower. It's how they consume pheromone, which is smells that bees give off. And it's how they sort of sense and feel their way around inside of a hive, which is very dark. So they use their antennas a lot. And so they're very important parts of the bees. They also have jaws, their mandibles that they can chew with, that they can chew wax up with. And then they have a proboscis, which is their tongue that comes out, and we'll see some videos of their tongues in action. But honeybees primarily communicate through smell, which is pheromone. They have different types of glands that emit different smells that signal different things, whether it's come here, this is where we're at, which is Nasanov, or oh, someone's in the hive, ooh, that's alarm pheromone, etc. So they have different smells, and then the queen has her own smell, the queen mandibular pheromone, which is essential to hive structure and order, and I'll discuss that down the line. But their antennas are vital in this part of bee communication. Furthermore, if you look inside of the bee, right, a few things to note is that, you know, bees have two stomachs. They have one stomach that they use to digest, you know, food. Also, bees have, you look at this, they have a rectum. Yes, they crap. Bees do crap. Hopefully not inside the hive. They go outside to do it. But imagine a long winter where you ain't leaving, you know, too much. But yeah, they do poop. Bees do poop. You will get pooped on by a bee at some point. But bees have a honey stomach. The honey stomach is really important. This is the stomach that carries nectar. Whether they're out foraging and they suck up some nectar, it doesn't go into their digestive stomach. It goes into their storage stomach, the honey stomach. And that's just very super duper important in terms of inside of the bees. All bees have 5 eyes. So, and they look a little bit different, and they have different functions in some ways. They have similar functions, but for different purposes. So we have the male bee, the drone bee. They have very big eyes. So bees will have the eyes that we typically see, which are on their heads, obviously. And these are called compound eyes. And these eyes are made up of many, many different lenses, thousands of different lenses, okay? And then they have 3 eyes on the top of their head, which are the ocelli eyes. And these are used for different purposes. So the compound eyes help them see movement, help them see shape, help them see color. So it allows them to understand, for foraging female worker bees, it allows them to see certain types of flowers. For drone bees, it allows them to see a virgin queen as she flies through so they can mate. For the queen, it allows her to see, to see, drones for mating purposes, etc. So they all sort of have, different purposes for those eyes. The ocelli eyes on their head all have a similar, function, or the same function, which is seeing light, which is seeing direction. So bees use the sun as a source of direction. So those eyes see that, and those eyes are simple eyes. They have one singular lens. Okay, but the queen bee will use this, to get home from her mating flight. Drone bees will use this to try to get home to their actual colony when they come back, and so forth. So it's important to understand that differences in those eyes. So here's a great video of bees drinking a little bit of honey. So let's just check this out. You can see their proboscis in action. It's a really nice little close-up video I got of some girls sipping some honey. See nectar on her wing. Bees obviously have 4 wings. They have 6 legs. See this girl in the background as she's fanning. Her booty's in the air. She is sending off a little pheromone to tell girls, come on up here, there's some golden goo for y'all to chew on. Okay, so let's talk about castes of bees. Listen, bees, as I said, are very structured, and you have 3 types of bees inside of the hive, and I've spoken of them already. So the first type, we'll say the most important, is the queen bee. And the reason why she is very important is she is the bee that lays eggs. And she is the bee that lays eggs that become female worker bees. And the female worker bees are so important to the hive because they do basically all of, guess what? The work, They do all of the foraging. They do all of the cleaning inside the hive. They do all of the maintenance. They do all of the depositing of pollen, of nectar, all of the fanning and refining of nectar into honey. They do a lot of work, straight up. Okay, and now if you look at this image, you can see our queen in the middle. She's got a long, beautiful brown abdomen, a hairless thorax. She's surrounded by some of her worker bees, some nurse bees. And then if you look right above her, you can see these two guys. These are our drone bees with their big old eyes and big fat butts. Okay, and their sole job is one thing. They have one job and they got to do it good, is to mate. And not just mate with any bees, right? To mate with a virgin queen. And I'll talk about this mating process later in our presentation, but they have one thing to do, and that's it. They don't do nothing else. That's the one thing that they are supposed to do, and that's the one thing that apparently they can do, and not all of them can do that. And we'll talk about that. You can just see the differences in the bees. This sketch gives you a sort of sense of the proportional dynamics of them. And it's very important to be able to recognize a worker bee and differentiate specifically a drone bee from the queen bee, because you have many drones during summertime and springtime, but you'll always only have one queen. And queen spotting is kind of hard. It takes a while to be able to do it. If you have a marked queen, it's significantly easier to find her. But if you have eggs, one egg per cell, you got a queenie. Okay, and we'll talk more about that. So how do bees develop? If we look at this beautiful picture here, you can kind of see all of the different stages of a bee as she transforms from an egg, which you can see they're little pieces. They look like little bits of rice in the bottom of the cell, and they should be sticking up straight. A fresh egg sticks up straight, and as it starts to hatch, it will hatch in 3 days. It starts to fall down. So fresh eggs are standing straight up in the bottom of the cell. Now, if you look at this image, and you look at, you can look here, and you can see that we have larvae. And the larvae look like a little C that are laying in the bottom of the cell, oftentimes in a little pool of white goo, which is royal jelly. And then if you look at these here, these little capped cells, this is where we have pupating larvae. So these are bees that are essentially in their cocoon that are pupating. And these specific capped brood cells are worker brood, and we'll talk about that. But worker brood typically is flat with a little dimple, and then drone brood looks like it has a little puffy, looks like a piece of popcorn. And then queen cells, pupating queens, will look like a hanging peanut shell, and we'll show all that stuff. So start as an egg, right? Hatches as an egg after 3 days, is a larva for about 6 days, and then queens, drones, and worker bees pupate for different amounts of time, okay? Now, mind you, when the queen lays an egg, if she shoots a sperm in it, right, that she's gotten through mating, that will then become a fertilized egg, which will then become a worker, a female worker bee. If she doesn't fertilize the egg, it becomes a drone. A single chromosome drones, you know what I mean? So again, a worker will spend 3 days as an egg, same as a queen, same as a drone. They all will spend about approximately 6 days as a larva. A worker bee will pupate for 12 days and then emerge on the 21st day. A drone will pupate for 14 days and change and emerge after 24 days. And the queen pupates for 7 days and emerges at 16 days total. From hatching, from being laid as an egg to emergence is 16 days for a queen. And if you look at this graphic, this just shows it in a different way. You can see the egg where it's laid, it's standing up straight. The queen's laying an egg, it slowly falls down. By the 3rd day, hatches, turns into a larva. Now queens, they're not in a cell like drones and workers. They're from a queen cell or a queen cup, which will typically be hanging down. So they emerge in a different way, and you'll know what a queen cell looks like when you see one, and we'll see one in a few minutes here. So one main thing to know is that if you look in your hive and you see fresh eggs, you know you have a queen. If you don't see fresh eggs, you can look and guess that, based upon how the larvae that are in there, if there are any, and the sort of their size, how long you've been queenless. But if you see, 1 egg per cell sticking up, you know that you have a queen in there, and that's good. Woo! So finding the queen, you may not need to do that. You just may see that there's fresh eggs, put everything away, and move on to the next colony, for inspection, or move on with your day. Now, if you see something that looks like this, a lot of eggs in a cell, this is not good. This means that you, first of all, don't have a queen, and because she's not there emitting her QMP, or queen mandibular pheromone, that the worker bees have developed ovaries, which the pheromone represses. They have developed ovaries, and now they're laying eggs, but they don't have a long, big, beautiful abdomen that can pinpoint drop an egg in the middle of the cell. They just kind of poop them in there, and this is kind of a mess that you don't want to deal with. Our larva, will look like a little circle, little C at the bottom of a cell. I guess like a maggot is probably the most, common way that we see larvae, but a much more beautiful maggot. But they look like a little C. And then pupa is capped brood. In this image, we have two drones who have been exposed, but pupa are capped brood, which are, when we talk about brood, we're talking about eggs, we're talking about larvae, and we're talking about pupa. They're all considered brood. So in this image, you can see a bunch of bees, and then you can see a bunch of pupa, capped brood. And in this instance, you can look at this capped brood, and it's got little dimples in it. It looks pretty flat, and that is worker brood. You got to know the difference, okay? You look at this thing, you got a whole bunch of different things going on here, right? This frame has, if you look to the far right, you will see puffy drone brood. Right below that, you will see capped worker brood, and these big, gnarly looking peanuts are queens. Okay, and when, basically what happens is the queen lays an egg, and when the bees are gonna swarm, or when they're gonna supersede her, or when she gets crushed, done that, squished, done that, shaken off by accident outside of the colony, done that, right? The worker bees will take whatever fresh eggs they have. They'll take several, 10, 12, 15, depending on what they have, or one if they only have one, and they will feed that larva only royal jelly, which is something that the bees excrete, young nurse bees excrete from glands, and they'll feed them only royal jelly, and those will become queens, right? And the first new queen to emerge will go and stab her sisters, and she will now be the new queen of the colony, go out and mate, and she'll go lay eggs. Okay, so that's just real important to know what queen cells look like, and queen cells will look different given certain situations. So if we look at this frame, you can see there's a couple queen cells hanging off of the bottom. Those are going to typically be swarm cells, meaning your colony is going to swarm. And to note, You can see a couple cells, queen cells or queen cups, which you'll see a lot of, and they're not necessarily queen cells until you see a larva in there with a bunch of royal jelly. Then like they're gonna have a new queen, they're gonna swarm, etc. But these get capped. We just know that on day 8, queen cells get capped, and that's when it's time to replace her, whatever it is. And then if you see them random at just any different parts on a frame, that's usually an emergency cell, meaning, oops, she died. Oops, our bee farmer dummy squished her, whatever. So you'll learn that they mean different things. I love this image. You can just kind of see the larva really good. You can see the eggs really good. And we can see our worker brood really nice, and just kind of see all the phases of bee development. So let's talk about the queen, the mama. Okay. Her main job, as I said, is to mate with a drone, right? Come back to the colony and lay mad eggs. And she lays 1,500 to 2,000 eggs during the entirety of every day, which is just crazy. Primarily spring through fall is when she's laying. She also produces a pheromone called QMP, queen mandibular pheromone. This is just so important. This is what all the workers recognize as her smell, and this also maintains colony order. It can signal, let's go forage more nectar. It's time for me to start laying eggs. It keeps the worker bees from developing their ovaries. They consume it with their antennas. They spread it around to all the bees in the hive, and it's what makes them know that they have a queen. It's just super important to the hive. Now, biologically, she's different from her daughters and her sons. She has a large abdomen. She has no stinger. She has no barb on her stinger. This is so that she can go and stab the hell out of her sisters, and she won't die, essentially, right? So worker bees, the barb on their stinger, they die when they sting you, but they only die to protect their hive. They only die and sting to protect their home. So if they're swarming or if they're out foraging, they have no home to protect. They're not going to sting you unless you sit on them or do something goofy. Queens will live 2 to 6 years. Approximately, they're pretty hairless. That's what makes them sort of easy to see. They don't have hairs for pollen collection, right? They don't produce wax, and they don't have any scent glands on their abdomen. Their abdomen is very particular in its function, okay? Now, unlike worker bees and drones, she doesn't eat honey. She doesn't eat no pollen. She eats only royal jelly. And royal jelly, again, is a substance that is produced through gland secretion by young worker bees that she's fed the entirety of her life. And she's the only bee that is fed this substance. Young larvae are given this substance for a few days, and that's what they're fed. But queen larvae are fed that the whole time as they go into pupation, and then for the rest of their lives. Okay, and the queen, she flies just a few times, once to mate, maybe twice if the weather is bad during the first mating flight. She may go out again. Okay, which is, you need her to get mated proper, so hope for good weather, and then she may swarm once or swarm twice and have to fly those few times. She's not meant for flying. She don't like flying. It's hard to fly with that big body, because once she mates with drones, she just fills up with their little swimmers, and she gets big, and it's hard for her to fly. And we'll learn a little bit about this when we talk about swarm biology. So we can see our queen here. She's laying an egg, sticking her abdomen down. Now watch the bees as they circle around her. That's called retinue. Okay?
I'm so proud of you.
Mm-hmm. I'm very proud.
You have made it.
But they're cleaning her. They're feeding her. Okay, they're consuming her QMP, her pheromone. Okay, it's very important. So Retinue behavior is basically these nurse bees that are sort of gathering around her. And you can tell that the more they're sort of gathering around her like that, the more they're sort of feeling her, the more they love their queen. This is what she does. She does not make decisions. She doesn't decide about swarming. That's all done sort of democratically amongst all the other bees. In fact, when they decide to swarm, the queen don't know. She don't know. All right, the workers. Well, guess what? It's all in the name, What do? They're workers. They're laborers, They work, and they work to death. Their whole 40 days of existence is work, and then they die. But they do it for the good of the colony, you know what I mean? Good of the superorganism. And to have a healthy, successful hive, you need a lot of young workers. They're very important. They provide food for young brood. They clean. They keep everything hygienic. They take care of the queen because they can only secrete royal jelly for the first, few days of their lives, and then they move on to other tasks, okay? Biologically, they're different in the sense of they have a smaller abdomen, okay, because they're not supposed to be laying eggs. They have a barbed stinger, which comes out, and they die when they sting. Okay, as I said, they can lay unfertilized eggs. They don't have a little spermie to shoot into the egg. And they live about 40 days, maybe 45 days, depending. Depending on the time of the season and the size and strength of your colony, you'll have 30,000 to 60,000 of them, which is pretty amazing. They eat nectar, honey in winter if they have to, but they prefer nectar or sugar water, as well as bee bread, which is pollen and nectar and saliva that ferments the pollen. They also consume this, okay? But only eat honey in winter and only if they have to. They'd rather not eat honey. It's just emergency. It's their, root cellar, or, their doomsday prep, whatever. Here's a picture of my son holding a beautiful frame of worker brood. It just looks really, really nice. Looks like a football. And what you have is all the brood in the sort of center of the frame, and as you get to the periphery, the outsides is where you have pollen or open honey stores or capped honey stores, resources for them on the frame. Now, typically worker bees will, spend half of their lives inside the hive and half of their lives outside of the hive. So worker bee, she chews herself out, she emerges, she cleans out her cell, and that's basically what she does for the first few days. Is she moves around the hive and she cleans cells. It's very amazing. She then graduates to being more of a housekeeper, and also caring for older brood, okay? Typically, right? They'll care for older brood, okay? And so they're feeding them. Then they will graduate for the next, 6 days of their life, 5-6 days, so days 6 through 11, to feeding young bees, feeding the queen, creating royal jelly and feeding that to bees within the hive, okay? Then they, can continue to be housekeepers, but they become distributors, right? So they start fixing cells, they start producing wax or recycling wax. They may be a receiver bee, so they will sit at the, inside the hive, and then a forager bee will come back with a honey stomach full of nectar. She'll put her mouth inside the mouth of her sister, and she will regurgitate or barf that nectar into her sister's honey stomach, and then she'll go and deposit that into a cell, and eventually the bees will flap their wings and they will dehydrate that nectar into honey. Bees will then, days 18 through 21 will be guarding and cooling the colony, whether it's fanning, moving water around to cool it, but also guarding the entrance. And then they leave the hive and they spend the rest of their lives foraging. Once they've been avid foragers, maybe they're a scout bee looking for a new location or home for a swarming colony to land. They could be undertakers who take out the dead, the sick, etc. So this is, the regimented, task-based development of female worker bees. So let's talk about the dudes, man. Here we have pretty much, a matriarchy. And let's not say pretty much. We have a matriarchy. Let's be honest, right? And then we have the drones, the bros who crash the sorority party, right? And we're talking about the sorority that doesn't like to party. They're hardworking, dedicated to school, blah, blah, blah. And then the bros show up and all they want to do is drink honey and lay around and not do their dishes, etc. So the drone has one job and one driving factor in their life, which is to score or mate with a virgin queen. If you've ever raised a teenage boy, just like a drone, they don't clean. Just like a drone, hey, guess what? Teenage boy can't feed himself. And also, most teenage boys, like drones, think with one thing or about one thing, and it ain't Fortnite. You know what I mean? But here we have a couple drones you can see next to our queens, just again to see the biological difference. We have a few workers on these cells, and then we have a couple drones next to her. So you can just again see the differences. So they have big eyes. That's to see a virgin at the DCA. The DCA is the drone congregation area. It's like a Tinder that exists about 7,500 feet in the sky, where drones go to hang out and wait for virgin queens who, know where the drones be at to fly through so they can mate. And we'll see a little video I made on that, some high art that I made where that shows that. Now, the thing about drones, they live about 30 to 60 days. They have no stinger at all, but they have a barb on their weenie, which means after they mate, the queen just rips that thing out. It basically explodes out of their body and they die. But they scored. And they succeeded, right? Because, as I said, the nature of bees, their drive of the superorganism is to reproduce itself. And you need the sperm. The drones, they're good for one thing. They get a little bit of a bad rap because they don't clean, because they don't cook. You know what I mean? They don't forage. They don't protect the hive. But they have an important function. They'll make up about 15 to 20% of the hive in springtime, late spring specifically, early midsummer. And then, what happens if they don't score with a virgin and die? The girls, when resources get tight and fall starts to roll around, they don't let them back in. They drag them out. They're done. So you die, unsuccessful. Otherwise, the other important thing is that, drones, they drift between colonies. So they're not really, allegiant to their colony. And maybe they don't have the best sense of direction. They drank too much honey and then went off to the drone congregation area looking to score. And, they come back and they don't know where their home is. Okay. They are unfertilized eggs, haploid, single chromosome drones. Okay, just another image of our honey bros here. You just want to know the difference between a drone and a queen specifically, because I remember when I first started inspecting hives, I thought I was always seeing the queen. I was like, hey, there's a queen there. Wait, that's not her. Oh, wait, she's right there. And it was always a drone until you really recognize that stuff. This picture is good. It shows you a little bit of worker brood, and then if you look at the puffy popcorn, that is drone brood. So just again, be able to note the differences in that popcorn puff is your drone. So here we go, the mating flight, the nuptial. This is me, as you can see, desperately in need of a manicure and fingernail cleaning, although that's probably propolis from the hive, holding a virgin, little virgin, okay? Now, what happens, as I said, the queen leaves the hive once to mate, maybe twice to mate. And what she does is she flies off to the DCA, and she does this, they go to this Tinder in the sky, to avoid incest within the hive. So she goes there, she'll mate with 15 to 20 drones, maybe one from her colony or two from her colony, but she goes there to ensure genetic diversity when she comes back and starts, laying and fertilizing eggs. So this is a little video I made that shows the mating flight.
Don't mind us.
We just need to get through here so we can score.
Yeah. Okay, now let's go score. Well, it's not the kind of scoring I thought I was gonna get, but it's better than nothing.
I think you scored. How was it?
It hurt really bad, and I think my nads caught on fire.
Here we go, bring it in. To virginity.
To virginity.
Get lost.
The success of a drone ends in failure, but you succeeded. Good job, lad. Now, when you look at a brood frame, this is very different than a frame of honey. A brood frame, what you'll see is a few different types of things. And you need to know not only the different types of brood, so queen, drone, and worker brood, you need to know what else is going on in reading a frame. So when you look, we have our capped brood. In this case, the pupating larvae are worker bees. Okay, it's flat, maybe a little dimple. You look up above, we have the beautiful array of different colored pollen. What we call open brood, if you look and we have eggs and larvae, we call that open brood versus capped brood. Then you can see uncapped honey, so that's called open stores, and then capped honey. Looks a little bit similar to capped worker brood, except for one thing you'll really notice is that the capped pupating larva, the cappings are darker. For honey, it's typically going to be very white cappings, white capped wax. So it just looks different. So what do bees forage? What do these girls go out and do? And it's just important to note that it is the girls. So if you ever saw a bee movie, you know that shit is wrong. It is wrong. Worker bees don't have no job. They have one job. Drone bees don't have no job. They have one job, right? One job only. That's it. So as we know, bees forage nectar from flowers, right? They do this for energy, for the carbs, man. And it's super essential. Nectar is really the driving force. You'll notice when we get to the end of this presentation, when I talk about, the season for beekeeping, is as nectar increases, so does colony size. And as nectar decreases, so does colony size. So nectar is the driving force. It is so important. It's what they want to eat. It's why they eat sugar water. They like nectar. And they will fly 1 to 5 miles. Now, they prefer to fly 10 feet. Because, as I said, they're opportunistic, right? They're very resourceful. Flying 5 miles to forage, when you can fly 40 feet, whatever. Okay. For protein, man, to get ripped up, right? They go for pollen. That's where they go for their proteins, Now, what happens is with the mix of their saliva, it ferments and turns into bee bread. This is very essential. Pollen's super essential to creating royal actin. Royal actin is the active ingredient in royal jelly, which is fed to, young larvae and also to the queen throughout her life, right? But it's super important to reproduction and reproductive health within the colony. And then bees also forage water. So, they will do this to regulate hive temperature. So basically, they'll use this to cool off a hive. Okay, and sometimes it will be fed to young bees, but they don't really eat it, consume it, chug water like we do. It's mostly to cool off a hive. So we look at some of these images. We can see our worker bee foraging nectar. There's also a video here of her drinking from a flower. here we have a worker bee coming back with a nice, basket of pollen on her rear leg. So you can see that that pollen basket is full. This is a slow motion video of bees coming back with a whole gang of pollen on their legs. Some pollen that has harvested, that I harvested, using a pollen trap. Just, again, beautiful stuff. And here are some girls drinking some water. All right, so I talked about this a little bit earlier, that bees communicate through scent, which is called pheromone, and through movement, which we'll call the waggle dance. And these are two super important ways of communicating. So basically, as I said, their antennas are the main sort of sensory, organ or sensory component of bees, and they use this for so many things, but primarily to consume pheromone. Right? It's how they know, how to receive and what certain smells mean, and so it's a very important thing. So this will help to determine, what they do within a hive, what they're foraging, or when they should be foraging. It will also create a defense mechanism within them. It helps to signal swarming, to stop swarming. Basically, just real important. So the ones you want to know are, I've talked about queen mandibular pheromone, which is just vital, and we'll see a video here in a second. Again, that illustrates retinue behavior. The other couple pheromones, and there's quite a few of them that you want to know, is Nazanov, which is basically, if you ever see bees, when you catch a swarm or you see bees at the entrance of a hive with the booty in the air, fanning their wings, that's Nazanov. And that pheromone is basically to signal to their sisters, yo, here where we at, come over here, come here, right? So when you catch a swarm and you chuck them in a box, and some of their sisters are out scouting locations, you'll notice they'll all sort of stick their boots up and fan those pheromones out. Alarm pheromone. And actually, before I get to that, Nazanov smells like lemongrass oil, if you've ever smelt that. So we will often bait swarm traps with lemongrass oil. And so if you recognize that smell, you'll know when they're producing that pheromone. If you have ever eaten a banana Laffy Taffy, I can't even imagine, but banana Laffy Taffy supposedly is what alarm pheromone smells like. Maybe get familiar with that. If you notice you're getting stung a lot and they're getting mad, they're flying out towards your face or towards your veil, the alarm pheromones are off. Intruder alert, right? Recognize that smell or recognize the behavior of the bees and then take a whiff and then, move on, right? So that's why we use smokers. So when you smoke bees, obviously part of that is it signals that, or it tricks them into thinking that a fire is happening, a wildfire is happening, so they go and have some honey and they chill out or whatever, get all honey drunk. But the real thing is that it covers up the pheromones. It covers up the scents. So they, oh shoot, you squished a bee, and they don't like that, or you're pretty aggressive with handling them, and they start throwing off that alarm pheromone, the smoke will cover that up, and that's mostly why we use smoke. So what is the waggle dance, yo? It's basically how they communicate, the location of water, the location of really dope and really amazing nectar, really sweet, yummy, sugary nectar. It's how they communicate that, or it's how they, communicate directions to a possible new location when they are swarming, whatever it is. And it's, we'll see a video where they basically, they shake their booties and then little circles, and the more they shake, the more excited they are about whatever they have found and want other bees to go find. And the way that they move also signals basically GPS coordinates to where to find this awesome sauce. So we watched this video.
One of our brand new queens here at Goat's Beard.
All of the workers surrounding her.
Freshly tagged for
She's about to lay an egg, and watch as they clean her, feed her.
Look at that retinue.
Yeah, I call it retinue in the video, but it's retinue.
Yep. She's one
Very
of the
nice.
girls who got out during the shit weather.
And then here we have a video of the waggle dance.
Shake your ass, watch yourself. Shake your ass. Some of us are working with it. Shake your ass, watch yourself. Shake your ass. Shake your ass, watch yourself. Shake your ass. Some of us are working with it. Shake your ass, watch yourself. Shake your ass.
Some original content right there. All right, so what do bees make? Listen, we all know this, the golden goo honey. Honey is refined nectar, okay? So do they make honey? No, but kind of. They refine, basically dehydrate nectar into honey, into the golden goo, baby. Stuff we all love. So it takes about 8 pounds of nectar to make 1 pound of honey. Bees also make wax. They secrete this through pores in their abdomen on their underside. It's a pretty cool thing if you ever see it. It takes a lot of honey, 8 pounds of honey to make 1 pound of wax. And each 10-frame box that you have of drawn comb is about 1.5 to 2 pounds of wax. So you're talking 16 pounds of honey, which is over 100 pounds of nectar it took to create those couple pounds of wax. So when you render wax after you harvest honey and you're like, oh my gosh, I have a half pound of wax, a little ball of wax. It really is like a really amazing substance. I think the thing is, one of your most valuable resources as a bee farmer is drawn honeycomb, because bees only make it during certain times of the year. If you have drawn extra comb, you can always drop it in to a split, or into a swarm you catch, and the queen can start boom, 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 laying eggs in there. Or if you have honey supers on, you can just drop it in. They don't have to draw wax. And instead of spending that nectar on drawing wax, they can just put that in and deposit that into the cells. It's a really important thing. You see this image, you can see naturally drawn honeycomb. So bees will draw it sort of down in semicircles and then fill out the rest of the frame. It's really a beautiful thing as you watch them sort of fill out a frame. That's if you don't use foundation or plastic frames, what have you. And how they do this is, you'll notice them in this picture here where you see bees hanging on to one another. All legs are wrapped around one another and hanging off each other. This is called festooning, and they'll grab onto the top of a frame, or the inside of your house or the inside of the tree, and they'll festoon and they'll secrete the wax, and that's how they'll build their hexagon cells. And the important thing is that the cells are not they're at a little slight angle. That's why the nectar doesn't fall out of them. So it looks like they're, if you're looking into them, it looks like they're flat, but they're slightly angled down, so everything sort of stays in there. And the hexagon is a very easy to make shape and highly structural sounds shape. So festooning is when you see them hanging from one another, and they'll often do this to draw wax. And lastly, propolis. Propolis is what makes a hive sticky. It's not the honey, it is the propolis. It's what makes your frames stick together, or what makes the dog ears of your frames stick to the box. It is my favorite substance inside of a hive. It smells really amazing, like fruity amazingness, but bees make this by foraging resin or tree sap, and they mix it with wax, and it's what we call bee glue. They use it to seal cracks, but they use it to seal cracks to keep drafts out, to keep moths out, to keep other pests out, to keep disease out. They also go to it for immunity. It's a really amazing thing. It's probably, for me, once I started farming bees and consuming propolis, I got rid of all my seasonal allergies. I'm talking tree pollen, I'm talking grass seed pollen has been severely mitigated due to this. It's like my favorite thing. But propolis is, antifungal, antibacterial, antiseptic. It has lots of health benefits for humans. Definitely one of the best things that you can harvest from your honey supers after you've harvested honey. Great thing. So royal jelly, we talked about this. This is a substance that's made through a gland that is excreted. It's called I always wait till I butcher this, the hypopharyngeal gland. I just have always called it the brood food gland. Okay, just easier, not scientific, but hey, it is what it is, right? Young nurse bees have this. The gland is located on the side of their heads, right? And that's where they produce royal jelly. And the active ingredients, royal actin, and it links to pollen. Okay, it's this milky, gooey substance that you'll see in the bottom of cells or larvae sort of embedded within, right? Young workers can make this from day 6 through 12, and that's pretty much it. It's all the queen eats. Some people harvest this stuff as well, but anyways, it is some royal substance. Okay, some good stuff. So they also make that. Just some images of me marking a queen here. A lot of people don't mark queens. I do it just so very easy for me to see her. It also, you tag them by color code for years, so you know how old the queen is if she's in her 2nd year, 1st year, 3rd year. 4 year, I've never had that, but you never know. So just something you can do. And that, really brings us to this part, which is understanding our season here in the Willamette Valley bioregion. This is very important. We have a super short season. We have a few months, and essentially our beekeeping season starts on spring equinox. On March 21st, essentially, that's when it really starts to go. So if you have hives, that's when you are, doing full inspections. You're booging, you're treating, splitting or equalizing, etc. So if you look at this graph, you can see as we go horizontally, it's going to show you, time of the year. And as we go vertically, the green and yellow lines are going to show you both the increase in nectar flow, which will correlate with the increase in bee population and brood rearing, as well as the yellow line, which will show you the decrease in nectar flow, moving towards what we call dearth, and the decrease in colony size and population. So what happens around February, January, depending on the weather, if you get, warm-ish weather above 50, 55 degrees, they'll forage a little bit. They'll go for things like hazelnut, alder pollen, and nectar from willows or pussy willows. So they'll get the pollen and the nectar from pussy willows. Not a lot of nectar popping around this time of year. Then we start to really move into initial buildup in March, okay? So nectar flow starts to happen, our trees start popping, right? The queen starts to rear brood. She starts making new bees after, not, laying eggs for most of the winter. In April in the Willamette Valley, and this is just general time frame, if we have good weather, things are different. If we have shit weather, things are different. You make yourself a weather nerd, you know what I mean? But in April, the nectar and pollen that's primary is maple. Now, because there's a dearth or decline in nectar flow during this time, the colony population, it does still continue to rise, but it rises at a little bit slower rate. What starts to happen around April is that bees start to make new wax. They start to really rear tons of brood, and that's when we start to get in April and May is to swarm season. So they get to a certain size, they get big enough where they go, sweet, it's time for us to reproduce our genes, baby. And they make some new queens, and then the workers go, all right, old girl, we leaving. And half of the workers take old mama queen and they fly off to a new place, and they leave, half their sisters back with 6, 12, 15 potential new queens who duke it out to be the next head mama of the colony. Okay? As we move to summer solstice, June, right? That's where we have, towards the end of June, the peak of our nectar flow. This is when you're going to have the biggest colony. This is when you're going to have the most nectar coming in, right? And our whole goal throughout March, April, May, and into June is to basically do this, is to manage our colonies through various techniques so that they get big enough that they're large enough of a field force that they can capitalize on the May and June nectar flow and produce mad honey, but don't get so big that they decide to swarm in May and you're basically sort of starting over building your field force. So we'll talk about that in parts 3 and 4 of our beginning beekeeper series. So, what they're primarily foraging during the primary nectar flow is obviously blackberry, both nectar and pollen, raspberry, crimson clover, maybe clover, red clover. Now, what happens after summer solstice is that nectar starts decreasing, colony size starts decreasing as we move into September and we experience dearth and fall and all, basically our season starts coming to an end. So what happens as we move into August and September is they're not making any more wax. There's no new wax, right? You start to see less and less brood, right? Less and less. When you have 2 boxes, what will happen is the top box, which will also have brood, there will be brood in both the bottom and top box, they'll stop rearing brood in the top box, and they'll backfill all of that with nectar that they turn into honey, and that becomes their winter store. So they'll live in the bottom boxes during winter and eventually move themselves up and eat their way up to the top. So that's something that's real important. Now, as they slowly stop rearing brood, you may actually go into your colony in September or August and see no eggs and think you've lost a queen. Now, that could be the case, but before you panic, look around and see if you can find old mama. As you move into late summer, they start foraging nectar and pollen from buckwheat, fireweed, thistle. Just be aware of what happens as we get into autumn. Now, with that said, you have now completed the first class in the Lane County Beekeepers Association Beginning Beekeepers Series. Bee Biology, Know Your Livestock with Andre Sirois, aka Dr. Andre Sirois. I really appreciate you coming to my TED Talk. Everybody who came to the talk on February 18th and had a good time, I appreciate y'all. Thank you. For everybody who came and checked out this video, I appreciate y'all too. Make sure to subscribe to our YouTube channel, and also follow us on Instagram. The handles will be coming up, and make sure to tune in to our upcoming meetings and upcoming talks on beginning beekeeping, and keep it locked here to LCBA, y'all. It's Andre. I'm out. Peace.